Robin, welcome, and thank you so much for joining our online series. We are very happy to have you with us. And I will just leave the word to you. So, Robin.
That's great. Thank you very much. So good evening, good afternoon, good morning, everyone, wherever you are in the world. My name's Robin Moffatt, and I work for Confluent. Confluent, one of the companies who work on the open source Apache Kafka project, and we have our own Apache Kafka distribution called Confluent Platform, a managed Kafka service called Confluent Cloud. And this evening, this afternoon, this morning, I'd like to talk to you about how you can use parts of Apache Kafka and Confluent Platform for building streaming data pipelines, which kind of sounds fancy. But before we can really get into the nuts and bolts of it, let's just talk a little bit about what Kafka is at its heart. People have different understandings of Kafka. Some people think of Kafka as maybe just a kind of a message bus or kind of a dumb pipeline for shunting bits of data around. But what Kafka is a distributed event streaming platform. You can use it at the heart of your business, of all of your systems, to integrate your systems in a loosely coupled, low latency, event-driven way, which kind of sounds kind of fancy. Let's talk a little bit in more detail what it actually is. At the very heart of Kafka is a distributed commit log. So everything around Kafka that we build is based on this idea of the log. And then we've got different APIs that sit around it, like the producer and consumer APIs, an integration API, and a stream processing API. But this concept of a distributed commit log is a very, very powerful one. And what it is an immutable distributed commit log. So something happens in the world, and we write it to the end of the log, and that thing has happened, and we can't go back and change it. The best we could do is maybe send another event to try and counteract that thing that happened, but it's immutable. It's append only. And because of that, it's got some very useful properties when we're building systems. So we have this distributed commit log, and actually to be able to use it as developers, we carve it up into what are called topics. And topics are ways of organizing the data, kind of similar to a database table, if you're from that kind of background. And here we have our different types of events that are happening in the world, things like clicks on a website or orders being placed. We also can store in topics, and topics are this sections of the log, this immutable, append-only, unbounded stream of events. Within these topics, we can also store information about entities like customers, or about a particular geographical location, or about a device, stuff that you would kind of think of as reference information, because these things still get created and updated and sometimes deleted. So these are also events that we can capture and store within Kafka. So the data that we keep in Kafka is persisted. It's stored in Kafka or on disk, and it's distributed and fault tolerant and resilient. And we can tell Kafka to keep the data for as long as we would like, as long as is appropriate to the business use of that data. We could keep a day's worth of clicks on the website, or a week's worth, or a year's worth of orders, or 10 years worth of orders, or order data or customer data for all time. It totally depends on the business use case. So we've got our topics, they've got our data in, and within the topics, we can carve them up into partitions. And partitions are our unit of scale, because each each topic, when we come to read it, we can actually start to read it in parallel with multiple different consumers, all reading little bits of those information, so scaling out across those partitions. Within a partition, we have guaranteed ordering of those messages as they arrive in the partition. So again, a very, very useful characteristic of it. The data that we put onto the log is actually just key value bytes. So maybe unlike writing to a database, where as a developer, you simply say, here is this string that I would like to write, or here is this big int that I would like to write. With Kafka, as a developer, you have to understand how am I going to serialize that data. Am I going to serialize it as Avro or protobuf? But it's up to you as a developer to understand how to serialize it, or if you're reading from a topic, how to deserialize it. And we have other bits of metadata. We have some headers, we have timestamps, and as well as the value, we also have a key. So our key value pairs plus other little bits of metadata. So serializing the data we can do in different ways, ranging from like really good ways on the right-hand side of the screen, sorry, the left-hand side of the screen, all the way over to kind of like fairly rubbishy ways on the right-hand side of the screen. With Confluent Platform 5.5, there's been support added for protobuf and JSON schemas. Support for Avro has been there for a long time already. But I would strongly encourage you to look at how you build your systems around Kafka and to strongly consider and strongly advise you to use something with explicit support for declared schemas, not just kind of like relying on like, yeah, it'll be fine, and we'll just kind of like write some data and we'll pass a schema file around ourselves and email it to each other when we kind of like decide to change it. By having built-in support for schemas, it gives you a great deal of functionality in terms of validating changes, making sure that you're not going to break things for other people using that data. So we've got this data in Kafka, and when it comes to reading it, because Kafka persists the data and it keeps it for as long as we've told it to, when consumers read the data, they can do so independently of each other. So we have a user who comes along and they'd say, I'm going to read some data from this particular offset here. So the offset is the position in the log, and they go to that place and then they just scan through sequentially. And then someone else comes along and they say, well, this is where I got to last time, and they keep on reading through. And Kafka will actually store that offset. Kafka will track where each consumer got to, and when they disconnect, it'll say, right, they got to this offset here, and then when they reconnect, it says, okay, well, you got to here, so I'll carry on reading through. And I mentioned earlier this idea of consumers being able to be grouped together. So we've got 3 different logical consumers here. We've got Sally, Fred, and George. But actually within those different consumers, you can have multiple instances of that consumer consuming that data in parallel. So that's where the massive scalability comes into this. Very, very quick scan through what Kafka is at a high level there, or a little bit of a low level, a bit of a high level. If you want to know more about it, go and check out these books. I'm going to post the link online at the end of this talk. I'll also be tweeting it, and I'll be putting it on the meetup notes and anywhere else where I can find to put it. But you can get these really good books which go into the guts of Kafka and the kind of like architecture ideas around it here. But let's talk about streaming data pipelines. That's kind of like the title of this talk, and that's maybe what you're here for, hopefully what you're here for. And when it comes to streaming data pipelines, this is one of the things that people build using Kafka. And sometimes they start off fairly modestly with it. They say, well, we've got some data. It's sat in this system over here. It's sat in a transactional database maybe, and we'd like to get that data from there over to somewhere else, maybe somewhere where we're going to offload it for analytics. We're going to offload it from our transactional database to somewhere else because it's cheaper to do, or it's more scalable, or whatever. And we can use Kafka to do that. We can use this thing called Kafka Connect, which I'm going to explain in a moment, to stream the data from a database, a full snapshot plus all the changes into Kafka. And then we can push that data from Kafka to Amazon S3. And Kafka here gives us some good properties. It can apply back pressure, it can scale, it's fault tolerant, and so on. We start to benefit from the loosely coupling part of the design. Because if our database changes, we simply hook in the alternative into Kafka, and our consumer just keeps on reading from the same topic. And because Kafka persists data, we can say we're going to send the data to S3. We can also say, well, we'll stream the same data to HDFS or anywhere else where we want to use the data. But this is kind of entry-level stuff. It's good stuff to be doing. Lots of people do it. But in a sense, we're just using Kafka to shunt data around. But if we think about what that data is and what we're probably doing with it at the other end, we're taking some data from a transactional system. It's probably normalized to put it somewhere else. If it's for analytics, we're going to be denormalizing it. So if we're copying it from one place and copying it to another and then processing it, we're possibly missing a trick here. Because what we could do is we could say, well, we've got this data in the database. And if we drill down a level, we can say, well, it's event data, and we've got some reference data here to do with who placed those orders. We could process that data as it passes through our pipeline, and we can use stream processing to say, well, every time an order gets placed, we'll find out who placed it and do that lookup data, the lookup on the data that we would have been doing downstream. We can do that within Kafka. We can use stream processing to enrich that data, to transform it, to aggregate it, to do whatever we want, write it back onto a Kafka topic, and then push it downstream to the consumer. So this is where we start to kind of like get a bit more clever with how we're using the technology, because we can do that processing within Kafka itself. Another benefit of doing this is that because we're using Kafka here, if our systems change at either end, as I mentioned, it's more loosely coupled. So instead of saying, well, we've got data in the database over here, and we have to change that application, and now everything else is going to change as a result, well, we can say, well, we've changed our order application. Our orders no longer reside in the database. Our orders now come from a new service that we've built, and that service itself is going to be responsible for publishing those events into Kafka. Everything else, though, remains the same. We've still got our customer information sat in the database. We've still got a Kafka topic of order events. It's just that they're coming from a microservice this time instead of from the original database. But we've still got a topic of order events. So assuming the schema is the same, we just have our same stream processor, which enriches them as before, writes them back to a Kafka topic, and pushes them downstream. If the schema is different, we could write another stream processor to kind of like modify the schema and do whatever. But by and large, the pieces remain the same. Instead of saying we've got orders being placed in an application, and we need to change that application, we're going to migrate from a legacy thing onto a new microservice thing, and therefore everything else has to change. It becomes much easier to make incremental changes to the architecture. So how are we going to go about building this pipeline? We're going to go about building it using integration and stream processing. We're going to get data in from places. We're going to push data out to places. And we're going to use stream processing to do it. So in terms of the integration, we're going to do this using something called Kafka Connect. So Kafka Connect is part of Apache Kafka. It's the integration API for Apache Kafka, if you want to call it that. And it lets you stream data in from systems into Kafka, and then push data from Kafka down to target systems. So you've got a vast array of different connectors available to you. You can use it for building end-to-end pipelines, pulling data in from a database and pushing it down to Elasticsearch, or maybe just to integrate with different applications. You've got an application that you're building that's going to be a Kafka consumer, but it needs to get data from MQTT, or from Postgres, or from other places. You can use Kafka Connect to stream that into Kafka to then drive your application. Or you could say, well, I'm writing an application, it's producing data to a Kafka topic. That data that my application is writing to Kafka, I also want to push that down to other places. I want to push that down to Mongo, for example. So we can use Kafka Connect and hook it up to different topics to push data down, or hook it up to source systems to stream that data in. And it's very easy to set up. You don't have to write any code around it. You just write some configuration. You say, I've got some data, it's sat in a database, so I'm going to use a JDBC source connector. It's going to connect to this database here, and it's going to pull in the data from these particular tables. As I mentioned before, you need to think about how you're going to serialize your data. When you're pulling your data in from your source systems, it's probably got a schema. It's coming from a database, it's got a schema. It's coming from many other places, it's almost certainly got a schema. And if you apply that schema when you ingest it, it makes the life for your consumers so much more easy. If you're consuming the data, you're going to connect to a topic, you need to know how it was serialized so that you can deserialize it appropriately. Kafka Connect, it's kind of like a pluggable architecture. You have these connector plugins here, which connect to the specific technology. You have converters, which handle the serialization and deserialization. And then you have what's called single message transforms, which optionally you can apply. You don't have to, but optionally you can apply. And these can be used to manipulate the data as it passes through the pipeline. If you want to go and get these different connectors and converters and so on, you can go to Confluent Hub to get these. And you can search for all different types of connectors. You type in the particular technology you're trying to integrate with and download it and install it from there. So that's how you do integration. Now let's talk about stream processing. My Zoom window is flashing away at me, so I'm going to have a quick look at that. If I can find my mouse cursor, which I can never do when I'm in full screen mode. OK, so there's just a bit of a chat there. So let's go back to the slide deck. OK, so we're building streaming data pipelines. We're streaming data in from source systems. We're pushing data down to target systems. But to get the most out of it, the most appropriate use for it, a lot of the time we want to process that data as it passes through. And what we can use to do that within Apache Kafka is the Kafka Streams API. So part of Apache Kafka, it's a Java library. You can build into your Java applications and use it to do stateful stream processing. But not everyone wants to be able to, or is able to write Java applications. So another option is to use the Kafka Streams API, but with a wrapper on top of it called ksqlDB. So ksqlDB, it's written on top of Kafka Streams, but it lets you use SQL to declare your stream processing applications. It lets you use SQL to declare these stream processing applications, to say I've got data coming in from this place, I want to filter it for this condition before I write it somewhere else. But ksqlDB also exposes the state that it calculates. So if we think about, we've maybe built an aggregate, we define that aggregate in ksqlDB, ksqlDB maintains that stateful aggregate, and we can query it using a REST API. So we have data coming in from Kafka, we build an aggregate, and we can query that state directly from our application. So the way ksqlDB works is, at the kind of like very fundamentals is, it's a consumer of Kafka topics. So you've got data coming in to Kafka from somewhere, anywhere. Could be Kafka Connect, could be an application using the producer API, it could be anything that integrates into Kafka. You then consume that topic using ksqlDB, and you can say, right, I'd like to process that data, and I'm going to write it back into Kafka. So we have a stream of data coming in, we've maybe got order information coming in. We say I'm going to apply a process to that data. We're going to filter it, we're going to look for a status of order status equals completed, and we're going to write a new Kafka topic that's being populated by the results of that query. So now we've got a new Kafka topic, but it's just a Kafka topic. So any application can consume from that topic, which is kind of useful because we could have applications that are responsible for when an order moves to completed status, then do this. So we can have event-driven applications that subscribe to this topic of orders that are completed, and we populate that orders that are completed topic with a simple SQL statement. Select star from orders where orders status equals completed, and it's a continuous query. But we can take these Kafka topics that we're populating using ksqlDB, and we can process them further. We can daisy chain these things. So we can say, well, let's take these orders that have been completed, and now let's build some aggregates on top of them. What was the total volume of orders completed within the last hour, broken down by business unit, broken down by however we want to analyze that data, and again, write it back into Kafka. Because from Kafka, we could use Kafka Connect to push that downstream to other systems. We can start to populate our data warehouse and Postgres or S3 or Snowflake or wherever we want to do our analytics. We can also use that data, as I mentioned, to consume within services, within applications that we're writing. They want to know about completed orders, or they want to know about the aggregate state as well. So we could say, well, within ksqlDB, we're going to build ourselves a materialized view, basically, that's going to take inbound transactions that are happening. ksqlDB, we write a SQL statement which says, select the sum of the transaction amount, group by account ID. And now within ksqlDB, we're maintaining this stateful aggregation. As every event comes in, it gets computed and added into this aggregation, which means that from our application, as well as subscribing to a stream of events, as well as, or instead of, our application may also say, I would like to know what the current balance is for a given account. So you can say, well, I'm going to do a REST call into ksqlDB and say, for this particular account, what is the current balance? What is the state of this aggregate at the moment? And ksqlDB will say, well, here is the current balance. So it's very, very powerful because not only can we query the state directly, we can subscribe to a stream of events. So this is why it's called ksqlDB. It's an element of a database. We have a change log, a stream of changes coming in here. We're building a materialized view here, and then we can query that materialized view directly from our application. So let's have a look at how you actually build this kind of thing in practice and show it in action. What we're going to do is we're going to take some dummy data. It's a stream of ratings. So it's a website, and you can go to the website and say, well, I bought this thing, or I traveled on your airplanes, or whatever it was, and I'm going to leave a review. So like, I'm really happy with it, or I'm really not happy with it. And the data's got different characteristics. It's got things like a star rating. So on a scale of 1 to 5, was it really good or really rubbish? So 5 is great, 1 is awful. You could say, well, what was the device that left it? Was it through the website? Was it iOS? What was the channel through which they left the rating? And then a message, so a free-form message for the user to type in, like, we weren't happy, or we really liked it, and so on. We've got information about the user. So we've got a foreign key here out to information about our users. So we've got this data flowing into Kafka, and it's on a Kafka topic. The first thing we can do is simply push it down to Elasticsearch and say, in Elasticsearch, we've now got a kind of near real-time dashboard of what's happening in our application. So stuff's happening somewhere, events flow into Kafka, push that down to Elasticsearch. Nice near real-time view for analysis and reporting. But we can also say, well, those users that we've got, let's find out who they are. And we can find out who they are because we've got the user information sat, and as is often the case, in a database. So you've got the user information in a database. We're going to stream that into Kafka. So in Kafka, we'll have a snapshot of what's in the database plus every single subsequent change. And then as the data comes in, we can actually join out to the user information that's held in Kafka and enrich those events as they flow through. Which means not only do we have a view of the ratings that are being left, but who left those ratings? What kind of user are they? Are they like a really important user to our business? Because we also capture things like the user's status, like are they VIP, platinum, are they bronze, and so on. Because from that, you can also then drive different types of events. You might say, if a really important user comes along and they leave a really bad rating, maybe we want to have an application up here that's going to send a push notification to our service team and say, this really important user left an awful rating, and quite possibly they're never going to come back again unless we do something about it. So let's do a push notification, event-driven, to go and get someone to rectify that straight away. Let's take this information that we're enriching, push that down to a data lake maybe, where we can do kind of longer-term analysis on it. So let's actually go and have a look at how this is going to work. Uh-oh, my screen is frozen. OK, I think we're back. Davis, is this still working? Can you still hear me?
Yes.
OK, good stuff.
Yep.
Cool. Where did it cut out?
It didn't cut out. Just you can just continue. Yeah. Fine.
OK. My something to do with my computer is not happy at all. So let's cross our fingers. This is actually going to work. So we're going to build out this demo that I just talked through there. And all of this code is on a GitHub repository that we publish. So it's this Confluent Inc. Demo scene repository. Again, I'll tweet the links. I'll post the links on the meetup group and so on for where you can actually find it. But this is the builder streaming pipeline one. And on here, there's a Docker Compose. So you can actually just do Docker Compose up, and then you've got the full environment that I'm running here, and you can play around with it. There's also a workshop, so you can go through this. And it's actually got like step-by-steps how to do this thing. So let me bring up my prompt here. And what I'm going to do first off is move these things out of the way. And I'm at the ksqlDB prompt. So ksqlDB is part of Confluent platform. And we can use it to do this stream processing that I was talking about, to actually build out these complex transformations and materialized views. We can also use it simply as a way of producing and consuming from Kafka and working with our Kafka cluster. So we can say, show topics. Tell me about the topics that you've got on the cluster at the moment. It says we've got a couple of topics. We've got one called ratings. That sounds interesting. Let's have a look at that topic. Now, if you've used Kafka already, and earlier I was saying on about deserializing data, when it comes to reading data out of a Kafka topic, you have to know how it was serialized. If you're using a normal consumer from the console, you would need to specify I'm going to use the Avro consumer or the console consumer. ksqlDB gives you a hand with this. It lets you say, just say, print this topic. And it goes and inspects the topic and works out, well, I reckon it's serialized like this. So I reckon it's serialized as Avro. So given that it's serialized as Avro, it goes to the schema registry, it pulls down the schema, and then deserializes it and shows it here. So we can see we've got data in the topic, we've got a timestamp, we've got a key to the data, and then we've got a value. So we've got things like the rating ID, the user ID, and so on. And at this stage, all we're doing is acting as a consumer of this data. Pull data off the topic, deserialize it, put it on the screen. But it's already quite useful because we can start to poke around the data that we've got on the cluster. But more useful is if we can actually work with this data and start to filter it. So we're going to do this. We're going to say create a stream against this particular topic. So in ksqlDB, we've got different types of objects. One of them is called a stream. And a stream is like a Kafka topic, except we have a schema declared on top of it. You can use ksqlDB with Avro, with Protobuf. You can also use it with JSON. You can even use it with CSV if you really want to. If you're using it with something without a declared schema, if you're using it with CSV, if you're using it with JSON, you would have to type in that schema yourself. So you say create stream ratings, brackets, here is my schema definition, like you were doing in the database with your DDL. But because we're using explicit schemas, because we're using Avro, we don't actually have to do that. But if we say describe ratings, tell me about this stream, it says, well, here is your schema. You have a schema to the data because it's stored for us in the schema registry. So this is why you should be using schemas in your data. So we've got this data. It's in a stream called ratings, and we can actually query that stream. So instead of doing print against the topic, which just says, I'm a consumer, here's everything, we can say, just show me these 3 different columns from this stream. So it's OK, I'll go to that stream, I'll deserialize it, and I'll apply that projection that you've asked for onto the data as it comes in. So this is the live stream from the ratings as they're being left into our Kafka topic. So we've got our star rating, we've got the device that was left through, and then the message. But better than this, we can also apply a filter. So we can say, let's take that projection as we did before, but now apply a predicate. So take just those fields from the particular topic, deserialize it, and match this particular condition here, and then only show those particular messages. So we're taking a Kafka topic, we're deserializing it, we're applying a projection to it, applying a predicate to it. So far, we're writing it to the screen. Fairly uninteresting, useful for inspecting the data that's flowing into our system, but not necessarily so totally useful. But now let's write this back to our Kafka cluster. So we're going to do another create stream. So if I clear this and show you the queries that we ran before we said create stream ratings against this Kafka topic. Declare, in effect, a stream against this topic. Now we're going to do something different. We're going to say create a stream called poor ratings as the result of this continuous query. So that continuous query we saw before, that's what I was running a moment ago, that was echoing the results to the screen. But now I'm going to say, take those results as they stream in real time and write them into this stream. And the stream is backed by a topic. So we create the stream. It's OK, I've created the stream, I've created the query. If I say show streams, it's OK, you've got a new stream here, and it's backed by a Kafka topic. And if you don't believe me, I can say show topics. And it says, there is your Kafka topic. And if you still don't believe me, I can say, well, print the contents of that topic. And it says, here is your Kafka topic with the values within it. So we've got our timestamp, and we've got our key, and we've got our payload just of those fields that we asked for. So we've taken an existing Kafka topic, we've registered it with ksqlDB with one SQL statement, and then we've filtered it back into a new Kafka topic with a second SQL statement. And when I did that create stream before, I didn't actually specify the name of the topic. I just said, just create the stream. And so the topic was inherited from the stream name. But I could have specified the topic name. I could have specified the partitioning, the replicas, and so on and so on. I could even have said, take this particular one here. In fact, let me show you. Create a stream, and we'll call this as foo with value format equals JSON. I can say change the serialization. So we've got data in Avro. Let's change the serialization. Let's write it to a Kafka topic called foo. And now we've got another stream, show streams. Here's one called poor ratings foo. It's written to a different Kafka topic. and if I say print foo, it says, here is your new topic. The value format is JSON. You've still got the data as before. The difference would be if I wanted to go back and use that topic as a consumer, I would just have raw JSON. So I'd then have to guess at what the schema was and what the data types and so on. I wouldn't have an explicit schema defined for me. OK, so we've created this derived stream. Let me just show you exactly what we've done here. We've got a stream of ratings information, and that's coming in up here. So let's show you that in the top screen. Down here, I'm going to run a second ksqlDB console session. And in this one, I'm going to print out the contents of the topic that we created. So at the top here, this is all of the ratings that are coming in real time. At the bottom here, this is the new topic that we created, the per ratings one. And if I search for stars here in the console just to highlight it, you can see we've got every single rating is coming in here. So 1s and 2s and 4s and so on. The one in the lower part of the screen, this is just 1s and 2s, where stars is less than 3. So it seems like I'm laboring the point, but what we're doing is really, really useful. We're taking a Kafka topic with particular schema. We're applying a schema to it. We're getting the schema. We're applying a projection to it. Just pick out these fields we're interested in and filter it and write it to a new Kafka topic. But we can do even more than this. So let's cancel that and clear that. And up here at the top, we're going to take this data with our user ID. So we've got information about our users, but we don't know who they are yet. We're going to pull that information in from a database. So let's close that. And now we're going to use Kafka Connect. So Kafka Connect, it's part of Apache Kafka. It's controlled through a REST API. So you can just use a curl command against it. You can manage it through a graphical interface like Confluent Control Center. You can also manage it through ksqlDB. So ksqlDB has got syntax for managing connectors. So we can say, create ourselves a sync connector, create ourselves a source connector. I've copy and pasted the wrong particular connector. So I'll change that for this. So we're going to create a source connector, pulling in data using the MySQL connector. So it's the MySQL connector from the Debezium project. So this is a particular connector that works against the bin log of MySQL. Although I'm using MySQL here, what I'm showing you applies to any relational database, because any relational database is built around the concept of a transaction log, and we can take that transaction log, and we can stream those events from the transaction log into a Kafka topic. And we can also snapshot the state of the database before we do it, so we end up within Kafka a full replica of one or more tables as we need them. If you want to know more about this, there's another talk that I do all about this particular aspect of integration. It's called No More Silos, Integrating Databases in Kafka. Again, I'll send the links out afterwards, or you can Google it, and it's on the interwebs already. So we're using the MySQL connector. Here's our particular database. Here is our table that we want to pull the data in from. And then there's some other bits and pieces down here. So we create the source connector, and then we say show connectors and make sure that it's running. And it says, yes, it's running. As it happens, we've got another connector in place already, which is my data generator. So all of those ratings, it's not actually hooked up to a live website. It is just a data generator. So Kafka Connect has got lots of different uses. We've got our data coming in. Let's have a look at that data. Show topics. So here's our topics. We've got poll ratings, we've got food, we've got ratings. Here's our customers' data. So if we just head over to MySQL and have a look at that data that we've got first. So here's my MySQL. So top of the screen is ksqlDB. Bottom of the screen, MySQL. Gets a bit confusing. There's all SQL command prompts. So in MySQL, we can say show tables, and it says you've got a table called customers. And in MySQL, we're going to say, show me the data. Show me the first 5 rows of data. And it says, there's your primary key, the ID, you've got first name, last name, email, club status. So this is that thing we're going to use later on to filter out those ratings, to look for users of a certain status like platinum, compare it to the star rating, and if it's a poor rating and their platinum status, we're going to route it off to a separate place. But for now, this is just our reference data. Okay, we've got a bunch of data in there, 20 different rows, and we've set up a connector over in ksql, show connectors. So ksqlDB, we've got a connector here called MySQL, streaming data from that particular MySQL table. So it's taken a snapshot of the table. It's got to request the system. It knows the SCN it got to. And then every subsequent change to that table in MySQL will get streamed across to Kafka. So let's see that. What we can do is we can actually just look at the contents of that topic. So here's that topic. Print the topic. I do this thing here, print topic from beginning. I mentioned earlier on that Kafka persists data. So the data that we have in Kafka is persisted for as long as we tell Kafka to keep it. So when I've been running my queries in ksqlDB so far, it's been reading from the end of the topic. It's been saying, I would like to just read the new messages as they arrive. But if I do that with this topic that we have from the database now, there won't actually be any data showing because the data has already arrived. So if we then read from the end of the topic, well, there's nothing until we make a change in the database. So we're going to say, read everything from the beginning of the topic. It says, well, there's the contents of the topic. You've got your timestamp as before. You've got the key, which is our primary key for our user. And then we've got information about the user themselves. So this is just dumping out the contents of that database table, but it's in a Kafka topic. Now what we're going to do, though, is we're going to create a new ksqlDB object. And this time, we're going to create a table. Previously, I created a ksqlDB stream. And a ksqlDB stream is just a Kafka topic with a schema. It's just an unbounded series of events, but with a schema. A ksqlDB table also has a schema, but it's much more like a database table. It's state. It's value for a given key. So our table is backed by a topic. Topics are the only kind of like method of storage within ksqlDB. It's all about a series of events, but it's about how we want to model them. It's about the semantics of how we want to work with them. So we could say, I want to look at a stream of changes to customers, and I'll show you that in a moment. But to start with, we're going to say, I want to know what the state is. So we create the table, and it takes it from this particular topic here. You'll notice I don't have to type in a schema because it's in Avro. And I can say describe customers. It says, here is your table, and it's got a schema. And I could also query it. And to query it, I'm going to say to ksqlDB, OK, when I run a query now, I would like you to go back to the earliest point in the topic. So auto offset reset, go back to the earliest point in the topic. And now show me the state from my table. OK, select the ID, first name, last name from my table, and init changes because it's a continuous query. And what we're going to end up with here is something in ksqlDB, backed by a Kafka topic, that's basically identical to what we have here in MySQL. So a relational database streamed into a Kafka topic materialized as state or viewed as state within ksqlDB. So we've got state, but state sometimes changes. So I'm going to run that query again, and you'll see it says init changes on the end of it. Because we're going to say, if the state changes, then show me it. So we can we're subscribing to a stream of changes in that table in ksqlDB. So down in my database, in MySQL, let's go and change the state. Let's go and create a user. So obviously, you've got an API for your application that somewhere writes down to the database and does an insert and say, here is a new user. We've created a new user. But we're just going to do that directly here. Create a new user. Insert into the customers a user ID with the first name and last name. ksqlDB says, oh, the topic has got a new event in it. So we're going to materialize that state. We're going to write that state because the state has changed. We're going to emit that state. So we've changed something in the database, and we see that straight away in ksqlDB because the Kafka topic picked it up, because Kafka Connect is subscribed to that bin log, and it captures the changes out of the database into a Kafka topic. What happens if that state changes again? Because we created the user, but we forgot to specify their email address. Let's update that row for that particular key. And now if we go and query the database table, so select from customers where ID equals 42, MySQL says, here is the state of that row. If we go to ksqlDB and say, what is the state for this particular key, where ID equals 42, it's going to say that's not right. Emit changes. It says, here is the state for that key. For this particular key, here is the current state. And if we change it again, so we say, well, we need to set a status for that user. So in the database, in MySQLDB, we do an update again and say, set their club status. ksqlDB says, OK, the state has changed, I'll re-emit it. And then we say, well, obviously it's Rick, so the club status should be platinum. So we make the change in the database down here. ksqlDB says, OK, the state has changed again. So I have a series of state emissions. But if I go to ksqlDB and say, run that query again, tell me what the state is. It says, well, here is the state. And the state is platinum. If we go to MySQL and say, what's the state for that key? It says, well, I'm a database. All I do in life is give you state. And so here is that state. What's the state? We're getting state from a database. We're capturing the changes to that state into a Kafka topic. And we're taking that stream of changes and we're viewing it semantically as state in ksqlDB. There's this thing called the stream table duality that kind of describes what's going on here. But we can also take these changes and we can take the same Kafka topic and we can view them as a stream. So let me show you this. We're going to take the same Kafka topic. So if I show you what I ran before, we said create table customers against the Kafka topic called customers and the value format Afro. Now I'm going to say create a stream called customers stream. It's not an original name, with exactly the same topic, exactly the same serialization format. We're taking the same topic, the same events, the same stream of data, and we're looking at it in a different way. We're using different semantics to work with it. Because this time we're saying, I would like to know about the events. Okay, a stream is a Kafka topic, unbounded events with a schema. So you say, okay, tell me about the timestamp of the event, the ID, first name, and so on, from the customer's stream for this particular key. It says, here are those changes. First, we created them, and then we specified an email address, and then there was a club status, and then there's a club status change. So this is our stream of events. And we can go back and we can query that, and we can say, how many times did the state change? Or at what point did they become bronze? Or when did they change their email address? A stream of events is useful in itself. So is state. We can run the same thing, but say, tell me about the state. It says, well, here is the state. And the state is this. But it comes from the same topic. Whereas if we have a database with state, that's useful. And someone says, well, when did they become platinum? And you say, well, OK, let me go and change my data model to capture that data in a different way. Slowly changing dimensions or an audit table or some other stuff. If you work with events as your fundamental unit of data, you have access to both already. OK, let's bring this into practice. Let's actually take this table that we've built of customer information that's updating in real time from changes to the database, and let's join it to these events that are happening. So here in ksqlDB, we're saying select the rating information and the channel it was left through from the ratings stream, do a join out to customers on our primary foreign key relationship, and pull in this information from the customers. We can do functions in ksqlDB, we can rename schema objects and so on and so on. So now we're pulling in a live stream of events, and this is going to suddenly go like and scroll through the screen because we set the offset back to earliest. So it's going to go back to the beginning of that ratings event topic, and the rating events are being generated from like about an hour ago. So it's going to go through, it's going to enrich all of those and write them out to screen. And at some point it might slow down and just catch up to now, which is the, and it'll just start trickling on through. It's not doing that, it's boring to watch it. Much more interesting is to say, let's write this into a Kafka topic. So we're going to say clear that, do exactly the same thing. Okay, so run that exact same select, but this time persist it to a new stream, create stream as select. This time we're saying, well, write it to this particular Kafka topic. So we do that. We're saying set the offset back to the earliest, because when we write these stream processing applications, in this case here, we want to say process all of our existing ratings as well as every single new one that comes in. So now we've got a topic called ratings enriched. And we can go and have a look at that. We can say show topics. It says you've got a topic here called ratings enriched. And we can say print ratings enriched. And it says there's all your data. Again, we've gone from the beginning. So let's actually change the offset back to latest. So now we're just going to be looking at the latest values as they arrive into the topic. Okay, so you can see the timestamp there. If we just pause that, so 1448 UTC, it's 548 in England, it's 648 on the continent. And we've now got our enriched data flowing into a Kafka topic. We've got information about the rating, the message, the star rating, and the user themselves and their club status. So we've got a Kafka topic of ratings information. We've got a database table of customer information, both of them streaming into Kafka. We've written a ksqlDB statement to model both of those inbound topics. One is a stream, one is a table, and then another ksqlDB statement to do a join and write those out to a new Kafka topic. And that's all we've had to do to create this stream of data. So now let's create ourselves another stream. And this stream is going to be taking that idea of wanting to look out for users, our customers who are super important users, they're platinum users, and they're leaving reviews which aren't great, where the star rating is less than 3. And we're going to write this out to another new stream. So we're taking that ratings information that we just enriched, we're daisy chaining that, and we're saying, like, now apply another predicate. Because we want both things. We want this full stream of information for every rating that comes in, enrich it, write it back to Kafka, because we're going to use that in multiple different places. But we're also saying we would like a separate topic. So show topics, we create a new topic just of platinum users who are unhappy, because we can subscribe to that topic directly in a separate service and say, every time we get an event on this topic, we're going to do something and notify someone that this particular important customer is unhappy. What we're going to do now, though, is we're going to push this information down to Elasticsearch. So we're going to say, create ourselves a sync connector. So again, here comes Kafka Connect. We're going to use the Elasticsearch sync connector. I'm using ksqlDB as the kind of like control layer here, but you can use the REST API directly for Kafka Connect if you want to. Here's where Elasticsearch is. I would like to take the data from these two different topics. I'm going to send that down to Elasticsearch. So show connectors. It says you've got 3 different connectors. All of them are running. And now we're going to head over to Kibana. So Kibana is a front end that sits on top of Elasticsearch. Very, very useful tool. And this is going to show us that data as it's arriving in Elasticsearch, hopefully. Not too much luck with my computer today, so maybe this is going to go wrong. That's always the fun thing about live demos. They'll work 20 times out of 21, and then the one time it doesn't, it looks really lame. OK, well, we've got some of the data. The dashboard itself is broken. You can go and look at the GitHub repository and see a pretty screenshot of it. But what we've got here is if I set this to actually refresh every 1 second, which is kind of a fairly bad idea from performance, but it's going to work. We can take that and we can see that data refreshing all of the time. There we go. And so like I say, 1751 in the UK, we're an hour behind Oslo, but you can see the data is refreshing all of the time. So we've got a live stream of data coming into this particular Kafka topic. It's been joined and enriched and written into Elasticsearch. And then our dashboard here is updating every second to show those new messages as they arrive in. Right, let's push our luck a little bit. So that's not worked as it should have done. What you should have seen is this lovely dashboard here, where you're actually taking that data and segmenting it and analyzing it, visualizing it. But I'm going to see if the demo gods are going to be on my side for a last little bit here, which is where we're actually going to take this data and we're going to build a materialized view off of it. So let me open up my demo cheat sheet. And we're going to do that and this. Like I say, all of this code is on GitHub, so you can go and try it for yourselves and see if you can work out where I went wrong in my demo. And we're going to build an aggregate that's going to look at every rating that comes in. For every customer that we've got, how many ratings have they left within a given time frame? So this is going to be a table that we're going to create, because a table is a value for a given key. And if you think about an aggregate is a key with a value. The key here is made up of the customer ID plus also the window part of the aggregation. So let's create ourselves a table of that particular statement there. We don't need to run it first. So create a table, ratings per customer per minute, as select the customer name, how many ratings they've left from the ratings with the customer data. So again, we're daisy chaining these things here. We've taken the events, we've enriched them, we've written to a Kafka topic, a ksqlDB stream. We're now going to aggregate them. Let's change that window because like a minute is fairly silly. So let's say 10 minutes. Group it by the customer name. And that's going to create a table. So show tables, ratings per customer per 10 minutes. That's also backed by a Kafka topic. And we can query this data. So we can say, for a given customer, tell me about how many ratings they've left per window segment. So this is not going to work because we've changed the offset. Sometimes a demo is best just left broken. So what we can see here is we've picked up the first window. What it should have done was go back to the beginning of time and kind of calculate all of the aggregates. But we've got some data. We can see for the start timestamp here, this particular window, so 10 to 5 UTC, the customer had left 5. But then they came along and they left another rating. So the aggregate updated. And because we said emit changes, we've subscribed to a stream of these changes. And so every time it changes, we get that update. So this is what we call a push query. So if you've got an application that wants to know, as the state changes, I would like to know about it, you subscribe to that. And ksqlDB has got a REST API. So you simply hook up to that and say, I'd like to know every time that state changes, and then you can receive that information in your application. But you might also want to say, at this point in time, how many ratings has this customer left for a given time window or set of time windows? And this is called a pull query. So this is that idea, like I talked about earlier, of an application being able to go to ksqlDB and to query that state directly. So here we're saying go to the same table. I'm going to say where the window start time is the 5th of May. Because we're using UTC here, we're going to say where it's greater than 1630. And it says, well, there's your answer. And you'll notice here it says query terminated, okay? Because it's a pull query. We find out the state, we return that to the calling application, and then we're done, we finish. So it says in this particular window here, there were 14. And we might say, well, has that changed? And we say, well, we'll run it again, we'll find out. It says, well, there were 16. And if you start thinking, yeah, but I need to know every time it does change, then you say, well, that's fine. We'll say emit changes. And now we subscribe to that stream of aggregate changes. So push queries and pull queries, they serve different purposes. I want to finish up, since that little bit did actually kind of work, and show you how you can run that pull query using the REST API, using something completely different from the ksqlDB command line prompt. So here we're going to use Postman, just because it's kind of a useful way of sending REST queries. It's going against the query endpoint of ksqlDB. We're going to send that. And it's going to say, here we go, here is your answer. So you've got, here's the query that you ran. And at this point in time now, this particular user within that time window, they've made 24 different reviews. They've left 24 different ratings. If I run it again, that number's changed. Okay, it was 25. And I could subscribe to that and get a continuous stream of them. But any language, any client that can send HTTP requests and REST query REST endpoints can integrate with ksqlDB and this state that we're building with these materialized views. So that's the demo. As I say, I will put information about the slide, about the demo code and stuff like that online. If my keynote session, you can probably see it's doing a little beach ball effect. If that comes back anytime now, I will show you a set of slides with some useful links on them. Assuming that that's not going to work, my computer's just frozen. Let's see if we can find a PDF version of those slides. This is not the best setup for a demo. Okay, that's just frozen. So I'll do some questions in a moment if my computer comes back to life. I will put on Twitter, so @rmoff, that's me there. You can find me on Twitter. I'll put up on the javaBin meetup group a link to these slides, a link to the demo code that I ran. I'll put on the ebooks link, which I shared with you earlier. And I will now go and look at my Zoom to see if there are any questions that people have left. Apologies for the technical errors. Keynote is usually rock solid, but not today. Okay, so question number 1. How does Kafka know the number of partitions to create? Is the number of partitions equal to the number of consumers? So that's a great question. Kafka creates the number of partitions that you tell it to, and creating the appropriate number of partitions is a really key part of designing successful systems with Kafka. The number of partitions must be less than or the same as the number of consumers that you've got for it to make sense from a balance point of view. If you've got 10 partitions, the maximum number of consumers you can have within that consumer group is 10. If you have 12 consumers, you can have 2 that have got nothing to do because they have no partitions available to them. If you have 10 partitions and 5 consumers, each of those consumers within that consumer group will get 2 partitions. And if one of those consumers dies, then the partitions get reallocated, and one of the remaining 4, 2 of the remaining 4 will get additional partitions allocated to them. Back pressure, by that I mean if a receiving system is not able to keep up with the data coming from the source system, then it won't just kind of like bung up the pipeline. In this case, Kafka would actually keep on receiving the messages from the source system until the target system is able to receive them. And if the target system can't receive them at a certain rate, Kafka will supply them at the rate at which it can until it's caught up. Question 3, is Kafka performing stream processing itself, or there's a need to plug in an external system? So Apache Kafka has got the Kafka Streams API. So that is Kafka itself, which does stream processing. I've been showing you today ksqlDB, which is, I suppose you call it a plugin to an external system. ksqlDB is part of Confluent Platform. Confluent Platform is a distribution of Apache Kafka. So you get Apache Kafka plus other bits, including ksqlDB. But Kafka itself does have stream processing itself called Kafka Streams. Question, is the schema of the projection pool ratings available in the schema registry? Yes, it is. So whenever you create a stream or a table in ksqlDB and you specify the serialization format as Avro or Protobuf, or if you don't specify it, but you're reading from one of those, so it just kind of like propagates it through, it will register that new schema with the schema registry. So yes, it will be available, which is great because then any other consuming application can access that schema. So that's why the schemas and schema registry is so very powerful, because it lets you loosely couple your producers and your consumers without having to say, well, we're going to standardize on this way of doing things. And someone else comes along and says, oh, but I can't work with that particular library, or I'm using a different language or something. And you say, oh, well, tough, this is how we're doing it. Schema registry, it's a REST API, numerous libraries for integrating with it. So you can just produce and consume in a nice loosely coupled way. Are those special schema types shown, for example, customer table special for ksqlDB? So ksqlDB has got its own data types. It's got like big ints and varchars and structs and maps and stuff like that. I think that's what that question means. If it doesn't, then please clarify in the chat window. Question, could we use ksqlDB for materialized views and not emit new events? So ksqlDB, it builds these this state internally. So when I say create table as select, that's building that state internally within ksqlDB, and it uses a Kafka table as its persistence layer. And it also uses RocksDB, which also uses Kafka in the background for the kind of like the in-memory bit. So that's how it works. You don't have to emit new events. You don't have to consume those new events. You can actually just query them using the pull interface. What is the latency of pull queries? Pull queries are going against the state store, which is held in memory. So it's low latency. It's difficult to quantify that because it's going to depend on each individual case. Isn't it very costly to create state from a stream? It's more costly than not creating state, but assuming at some point you're going to need to deal in state, whether you're talking about analytics or whether you're talking about an application, state has to exist somewhere. So it's an efficient way of doing it to do it as part of a stream processor, because as the event arrives, you can update the state and do so and keep up with the throughput on your particular stream. With ksqlDB, with Kafka as a whole, it's sometimes worthwhile stepping back from a whole heap of assumptions that we have about how to build and deploy technology. We've always assumed that we have to have a database. We've always assumed that that's where you keep things, or we've always assumed that we have to have a local cache within our application or whatever. And sometimes you don't. And sometimes you can say, I've got a stream of events, and I would like to know how many of those there were in the last 5 minutes. And that by writing a SQL statement to express that and querying that makes just as much sense and is just as efficient, if not more efficient, than say, well, I'll take those events myself and I will write them somewhere and start calculating them. The state has to live somewhere. Question, how do you deploy ksqlDB to different environments? ksqlDB, it runs as a JVM process, just like Kafka, just like Kafka Streams, just like Kafka Connect. It's distributed. And just like Kafka Connect and Kafka Streams and the schema registry and anything else, it does not run on your Kafka broker. So your Kafka broker instance, machine, VM, whatever, is just for running that, and maybe Zookeeper, but a lot of people disagree. ksqlDB, you have a single JVM process, you have an additional JVM process on another machine, whatever. They can form a cluster. What you don't do is deploy ksqlDB as if it were your data warehouse and have like a huge number of ksqlDB instances within a single cluster. Deploying ksqlDB is much more about how you deploy an application, and you wouldn't have like one great big application deployment for every single function within your business. You say, over here, this is our fraud detection application. Over here, here's our order processor or our shipment notifications or whatever discrete units of work you've got, or however you decide to deploy them. The same thing with ksqlDB. You might have one over here for doing order notifications, one over here for doing something else, maybe one over here that's kind of like for just general sandboxing type mucking around, but you deploy them much more isolated than that. Question, could ksqlDB replace traditional database when querying millions of rows? No. So ksqlDB is very much about stream processing and about materialized view of state for driving applications. For ad hoc analytics, for like going back and forth through data and like filtering on huge numbers of predicates and so on, to do that in ksqlDB at the moment would be like doing a full table scan against your data. It would kind of like be horrible because Kafka is a sequential read. So when it comes to kind of traditional analytics, ksqlDB's role is much more in terms of massaging and kind of like ETL on the data to then put it somewhere else, like Snowflake or S3 or BigQuery or wherever you do your analytics, to get it into the state for querying and analytics over there. So I'm going to pause briefly and see if my computer is going to behave in terms of screen sharing so I can show you some really important slides. Let me see if I can kill that. Let me just load this up and then I'll get back to some more questions. So these are the PDFs that they're shared online. If you go to talks.armoff.net, you'll find them online already. But what we've got down here is some important stuff. Like I said, I'll come back to questions in just a moment. Confluent Developer is where you can go and learn a whole ton more about this stuff. There's videos, there's blogs, there's a huge number of tutorials as well for trying out these different things, both in ksqlDB, in Kafka Streams, Kafka Connect, and also just native producer and consumer Kafka APIs. We've got a really good community Slack for Confluent Platform. Go along to here, there's like 16,000 people on there, different channels. There's a Connect channel, a ksqlDB channel, a Streams channel, Ops channel, and so on. And then again, as promised, here are those ebooks, very, very useful stuff to get there. As I also mentioned, there's my Twitter, @armoff. Tweet me if you liked it, tweet me if you didn't, tweet me if you want to commiserate about Keynote locking up. But follow me on there and tell me if you liked it or not. And now let's do some more questions. So question, you can use REST with ksqlDB. What about security? How can you secure access to ksqlDB? So as part of Confluent Platform, you can apply security with things like RBAC and so on. You can also, I believe, proxy it. I don't know the full details on that. So come along to the ksqlDB channel on Slack and find out more there. What if you've got billions of events you need to reprocess in case the ksqlDB node goes down? Would it take hours to bring up again? So with the state that you have in ksqlDB and Kafka Streams underneath, it maintains that in RocksDB, and that's backed by a Kafka changelog. So within Kafka Streams, you can actually have standby nodes. I'm not sure if ksqlDB does this yet, but there's clever stuff that happens, certainly for Kafka Streams, in terms of minimizing the amount of time it takes to bring up a failed node. ksqlDB, I'm not sure if it's done that bit yet. Off topic, what fonts do you use in your Keynote presentations and your graphics? I think it's called Calam. If Keynote was running, I would open it up and show you. And the graphics I'll actually post, there's a blog I wrote. So armoff.net is my blog. There's an article about how do you do those drawings. Does ksqlDB expose any metrics to monitor its state with regards to high traffic streams and aggregation of them? Essentially to know if your ksqlDB is starting to chug. So yeah, so ksqlDB has got JMX metrics, so has Kafka Streams, so is Kafka. Confluent Control Center exposes a lot of this stuff as well. And you can also start to monitor your individual consumers through that. Last question, can you share some pro tips for troubleshooting, debugging Confluent Platform? Not in 30 seconds, I can't. How to view logs for connectors used. So troubleshooting and debugging is like a huge topic in its own right. Excuse me, there's a ton of really good stuff on the Confluent blog. There's confluent.io/blog. There's some really good talks from Kafka Summit. So if you Google Kafka Summit, you'll find the conference details from previous years. I think there've been like 3 or 4 years of it now. And within that, there have been talks about troubleshooting and debugging that go into like all the really interesting stuff, depending on which particular area you're interested in. So Kafka Summit in general has got really, really interesting videos and slides that you can go and access from previous years about all sorts of stuff. So if you want to know more about ksqlDB, more about Kafka Connect, more about Kafka Streams and so on, go over there and have a look at that. How to view the logs for connectors used. The Kafka Connect worker writes its logs to standard out, so you can go and query them there. It depends how you're running Kafka Connect as to where you'll actually find those. If you want to know more about Kafka Connect, I'm doing another online talk tomorrow. Hopefully Keynote will behave. It's called From Zero to Hero with Kafka Connect. If you go and look at LJC, so the London Java community, you'll find the details there, or tweet me, because I'll be tweeting about it as well. So that's all the questions. So thank you for everyone who's dialed in, who's stuck through the technical glitches. I'll share the slides and everything on Twitter and on the meetup group afterwards. Thank you.
Thank you so much, Robin. And thanks for taking time to answer the questions. I hope everyone had a nice time evening with us. Next week, we will have Martin Mulders talking about how to build DSL with GraalVM. So I hope to see everyone next Tuesday again at the same time. We will post all information on our Twitter account, javaBin. And once again, it was a great pleasure for us to be here with you tonight, Robin. And I wish you the very best forward. And with that said, I thank you for watching us and being with us today, and have a nice evening.